Hello everyone. Today we will have an example of an RC beam, reinforced concrete. We will simulate through Abaqus, and we will go step by step from parts, property, assembly, step interaction, load, mesh, then finally we will job. First, let's see our beam. This is our beam with details, reinforcement details, cross-section, dimension, stirrups, and the boundary conditions and the supported beam. Let's start with making parts. This is part. I will start with beam. 3D deformable solid extrusion 2000, just like for this, for the net, for creating the part. I will draw the cross section, then I will put dimension of the cross section. The cross section dimension was 150, 250. This would be 150, and this would be 250. Now the cross section dimension I've done. Then done. I'm just pressing on the wheeler instead of pressing here down. Now the depth will be 2000 as shown here, 2000 mm. Okay, now I have my first part, the beam. I will now go for reinforcement, the top bar. I will name it was the diameter. The diameter was, the top is 8, the bottom is 10. Okay, top 8, just to remember. 3D deformable wire, planar 2000, continue. Now, since it's 2000, I will take 25 mm from both sides as a cover. So I will left with 1950. Done. Then another one for the bottom bar. Bottom 10 diameter, same planar and same length will be. One 1950. Done. Now I have the bottom, I have the top. Now let's go for stirrup. Stirrup 8 also. 3D weapon, everything is the same. Now I will also take this cross section. I will take 25 mm as I said as a cover. So this was 150. After removing 25 from each side, we were left with 100 for stirrup. And this was 250. Removing 50, or 200 will remain. This is the stirrup, finish. Now we have the stirrup. Now we have beam, the bottom, the stirrup, and the top bars available. And now let's go to property. Property will create concrete material. The concrete will define elastic and linear and non-linear. The Young modulus, this is for the concrete I will use. This is the Young modulus, and this is Poisson ratio, 26,600, 26,600, and Poisson 0.2. Then I will go to plasticity to define the non-linearity. We have two models for concrete damage plasticity model and concrete smooth cracking. We will be using concrete damage plasticity model. The data required is the plasticity parameters, the compressive behavior of the concrete, and the tensile behavior with the damage, tension damage, and compression damage. The plasticity, I will put like this data 3101. This data I got it from a reference, and like this eccentricity and the ratio between biaxial, uniaxial. These are default value. You can check it from Abaqus data or Abaqus documentation, viscosity parameter. The default value is 0, but I will put 0.001 to help in convergence, especially reaching the failure. After reaching the failure, the compressive behavior, here the compressive and the inelastic strain, just copy, paste, and sub option, put the damage also, copy, paste, okay, tensile behavior. Tensile is like linear almost, like only when it reaches the peak, the failure will happen in kind of like define the damage also. Now we have defined the concrete material through concrete damage plasticity model, which is very much popular in simulating the concrete behavior. If you want to know like about details about these parameters, you have to go and read a little bit about the concrete damage plasticity model to know about dilation angle, eccentricity, the ratio between biaxial and uniaxial compression, the K parameter or like Tracker-Bracker parameter, and viscosity parameter. This is the concrete material. Okay, then now we'll define the reinforcement material or steel reinforcement. We'll define it as elastic phase first. Also, this is the data for my material. I'll use this young module. Poisson react 0.3 for reinforcement, then mechanical, plasticity, plastic, yield stress and plastic strain. We have to notice that like this is the normal stress strain curve, which is this. Now we need the true stress strain curve, which is this, using these equations. Then the plastic strain is nothing but only the full strain minus the elastic strain, as shown here in this equation. So I will take this from here, from the yielding, paste, yield stress, and then I will go to plastic strain and also paste. But this first one should be 0. Now this is how we define the reinforcement. And here we didn't consider the change in material of reinforcement depending on the diameter. Since we have two diameters, if you have the data for 8 mm and 10 mm, then you have to define two different materials, one for 10 mm diameter and the second one for 8 mm diameter. But here we just like have the same for both diameters we will consider. And to not forget, here while defining the concrete material, we just got data from a reference. This is from a reference we got it. You can get it also from like if you have an experimental data, you can have it from experimental data, which will be also more accurate. And you can use from references as I did, or you can use some models to represent the stress strain curve behavior of the concrete, like Hungestat model, for example. Now I define the materials, I will define the section. I have a section for beam, solid, homogeneous, continue. Now the material is concrete, and okay. And I need another section for reinforcement. I need section for top 8, which will be beam. I will choose truss to take axial forces. Material is steel. And the cross section, here I have to put the cross section of 8 mm. It will be like almost 50. And another one for the bottom bar, 10 dia, and steel, same material. And the cross section, let's calculate it. To be 78.5. Okay, and also for stirrup, also it's 8, so will not change from the top bar, 50 diameter. Okay, now after creating sections, now we need to assign. Since I'm in the stirrup side, so I have to assign the stirrup, assign. Here, create set, remove this, no need, I don't want to create set for this. I choose the stirrup. I press either done, or I can press on the wheeler of the mouse. It's like here. Now he's telling choose the section. Okay, this is a stirrup section. Now here he's showing me what type I choose. It's truss, and the material I choose for this is steel. Okay, everything is correct. Okay. Now I will move from here. I will go to beam, assign, no set, choose the beam. Now press on the wheeler. Here it's only one section, so it's the only one solid homogeneous. So it will only occur this. Material concrete. Okay, now we can see that the color has changed to green. If by mistake I have assigned another section for this part, like another time, now it will change its color to this orange color. So you have to know that you have done something mistake. So you go to the manager, here the section assignment manager. See, you have assigned 2 sections, delete one, it will come back to green. Let's go now to bottom bar. This is bottom bar 10, truss steel, okay. The stirrup is already assigned. And finally the top bar, top 8, okay. Now we have assigned, we have created the property, the material, and assigned it for each part. Now let's go to assembly. We press in instances, create instances, parts. I'll bring the beam and the bottom bar. These are bring them, and I will make the mesh dependent part. And okay. Now I will start using these tools to simulate and assemble the beam with reinforcement detail. I will start with translating this bottom bar. Okay, move it from this point. Here it shows everything on this bar, and like if you choose any tool here, he will ask you to do what to do. Like now he's telling me select an axis or a start point. Okay, I will select this is the start point. I'll select the end point. Okay, bring it here. Now it comes here. Now I have to rotate it since it's not in the right direction. This is the rotation tool. Oh, we have done a mistake. See, the bar has come back again to its original place. Why? Because we didn't affirm. Let's see. We will select again translate. We will select the reinforcement. This is the first point, end point. Now he's asking me, is the position of the instance correct? If you didn't say okay, it would go back to its origin, to the original place, and this is what happened. So I will say okay. This is what I want to do. Now I go to rotation, I choose the bar. Now he's asking me to select the axis. You can either use select the axis, or if I go back from here, he will ask you to select the point of the axis, like this is this point of the axis and this point of the axis. Then he will take, okay, this is the axis. Now the rotation angle, let's see, it is 90. Said yes, and yeah, it is. Now I got no reinforcement here, which is in the right direction. I just have to make cover from both sides, 25 mm. Select instances. Now rotation is done. Go back to translate. I will choose, now I choose both of them, reinforcement and beam. I will exclude the beam by pressing on Control and then choose the beam. It will exclude it. And if I want to include it again, I also press Control. I press Shift and include. Now the beam is included. If I want to exclude, I press Control and then I press on the beam. Now it's excluded. Now I have choose the member or the part I want to translate. Done. He is asking me start point. I will choose this start point. Okay, where you want to move it? I want to move it 25 mm in X direction, sorry, in Z direction and in Y direction, but in X direction it's minus 25 mm. So I will write minus 25, comma, on Y 25, comma, and on Z 25. Okay, I have done something wrong. Let's see what happened now. So it's not in the right position. I have done something wrong. Okay, I will tell him, no, this is not the right. Go back, please. Okay, now it's here. What I will do, instead of selecting the point, I will also go back, select the axis. I will select the axis. I want to go on this direction, on X, on this direction. Now he's telling me this, no, flip this, yeah. What is the distance? 25. Now I got here 25 and here 25. Position is okay, okay. Now again, translate, exclude the beam. Now on this axis, yeah, inside 25. Okay, now it comes inside. Now I want to give cover on Y direction. It's okay. Again, I choose, I exclude the beam. Sorry, I exclude the beam. Done. I choose the Y axis. It's showing down. No, flip. Top. Yeah, 25. Now it looks on the right position. See? You can see it's on the right position. I can press here. I can now see everything is visible. Okay. Now the bar is visible. Here this is the tree. Just I have two instances, beam and bottom bar. Okay. Now I have to make another bottom bar on the other direction. I can either bring another bottom bar, or I can choose this order array. I choose, I exclude the beam. Done. Now it has two directions. I only want to do it on for one direction only. So this is only one. Here I can choose direction, this direction. Okay, now he's asking me what is the distance. The distance is like the stirrup, the same distance of the stirrup, the horizontal of the stirrup. It will be like 100. Now you can see it's shown here because I can preview it. If I remove it, it will not preview. No, show it to me so I can see if it's on the right position or not. If it's not on the right position, this is one. See, I can flip it, but no, this is not. It was good. Yeah, it's inside. I can use this option to rotate a little bit and see it's correct. So okay, everything is correct. Now I have the bottom and the beam. Let's go for the top reinforcement. This is the top reinforcement. Okay. Again, translate this from here, bring it to the top corner, right position. Okay. Rotate this around this axis. 90, yes, it's in the right position. I have to translate. I choose, I exclude. I also exclude this bottom, only this top part I want. Okay, now select, I selected, done. Select, okay, this on this direction, not in this. Flip it, 25. Again, choose it, exclude beam in this direction. Okay, the arrow is good. No, not in this. I have to flip, 25. Okay, now go down also, the cover from top also, down, now flipped, 25. Now it's on the right position. I can check. It's like, see, it's on. It's almost on the right position. Now I will do order array to make the second bar. Done. Okay. Here, one. Dismiss. Shows the direction. This direction. What's the spacing? 100. It's not on the right position. Flip to that. Yeah. This now it's on the right position. Okay. Now I can see the longitudinal reinforcement. Bottom and top bars are located on the right position of the beam with 25 mm cover. Now I will move to the stirrup. I can press here, now the beam will come back again. I want to remove this beam to put the stirrup on longitudinal reinforcement. I can remove it from this tool, create display group, go to parts, beam. I want to remove the beam. Now I left with on the reinforcement. Bring the stirrup, please. Now this is the stirrup, translate. Okay, translate the stirrup from this point to this point, for example. Now he's telling me, is this the right position? I say yes. Now just to remember our work, we can see that the stirrup is starting just like above the boundary condition and this on 100 mm, 100 mm between the stirrup, the first stirrup, and the edge of the beam. So I have 25 from the cover, so I have to move it also 75 mm. So I choose it. Okay, yeah, it's on the right direction, 75. Now it's here. I said okay. Now it's in the right position. What is next? I have to make 1, 2, 3, 4, 5, 6, 7 stirrup. Distance is 100 mm. I use the array option. I choose the stirrup. Now see, it's in both direction, in this and top. No, only in one. The direction of the array is not correct, so I have to change it by using this. This will change the direction of the array direction. Now it's also not on the right direction. I have to flip. Yeah, now it's on the right one. 100. Yeah, it's 100, and the number was 7. 7 including the one you have chosen. 7 means including the one you choose. Like this is 1, 2, 3, 4, 5, 6, 7. Okay. Now what else? I have to now in the flexure zone I have 1, 2, 3, 4, 4, and the distance is 200. Again, array, choose this, and no, this direction. Flip, yeah, now it is okay. 200, 200, and the number was 4. If I remember. Yes, that's right. Okay. Now I left with the shear stirrups on this shear span. It's symmetry, like the same of this shear span. So I will directly choose array, this, 7, yes. Okay, now this is my reinforcement cage. Longitude reinforcement with shear reinforcement or stirrup. Just to make sure that I have done correct, the distance between this stirrup to this stirrup should be 1800 mm. How to check this? I can check it using this query information. Check the distance between this point and this point of this stirrup. It will show 1800, so it's correct. Now, no need to check anything else. Now my reinforcement is there. My beam is there. I can bring the beam by using this. Replace all, everything will come back. Now I have my beam and the reinforcement inside. I can use this just like you can see now through it. The beam and this is the reinforcement. Okay, now this is the assembly part. I go for step. I create a step. Step 1, I will call it loading. It will come after initial, yes, general, static, continue. Description, you can write any description you want. The time period, I will put it as 10. You can leave it as 1, but I would prefer to put it 10. The incrementation, the maximum number of increments, I will make it as 10,000, because if it reaches the maximum number of increments without finishing the load, the job will abort and will finish without finishing the whole load you have done. So it's always recommended to increase this number. The increment size in the initial, it's also recommended to put a very small initial step for accuracy. But here, just because we are doing an example, I will not make it that much small. I just like 0.001. The minimum, I will make it, I don't know how much 0. The maximum is 0.001, enough. And other, like, I will leave everything as default. Okay, now I have two steps, initial and loading. Dismiss. Now I have to put the bounding condition and the loading. I will make a test at the 3-point bending, like the load will be in the middle, in the center of the beam. And the boundary condition will be on the bottom. To make this, I have to make partitions on the beam. Let's see how, like the partition, we can make it in the part section. It will not have any kind of physical effect. It will only help in making partitions and in meshing and assigning some properties. Let's see how I will make partition. I will make the load in the center, so I will make partition in the center of the top surface of the beam. I will choose this order. Partition face sketch. We have many orders actually to make a partition. All these can be used for partition, but the face sketch is good enough for our job now. Done. Then I will choose the edge. This is the edge. I will put a line anywhere, and I give it dimension to be on the center. We know that it's 2000 mm, so 1000 will be. It's now in the center. Finish. Done. Now I have my partition on the center. It's not always that you have to put a line. Sometimes it's a space or an area. It depends on what kind of loading and how it's applied to the concrete. So just be careful. It's not always recommended to put a line. It depends on how the load is being applied on the surface of the beam. Anyway, for this example, I choose it as a line. Now I will also make partition to the bottom surface of the beam. Same order. This is the face, and this is the face here, done. And now I will take this edge just to show you what is the difference. It's just like the position will change. Again, I choose line here for the boundary condition, to assign boundary condition. The boundary condition, if you remember, it's also like it's 100 mm from the edge, from both sides here and here. (100), also from here to here, 100. Done. Now I have the lines for the boundary conditions. I'll go back to assembly. Now you can see also the partitions are here showing in the assembly. I will also make a reference point for the loading where I will apply the load. I can make tools, reference point. I will make the reference point to be just like above this point, a little bit. How I will do it? I will make inquiry point. Now it will give me the position of this point. Okay, position of this point. Done. Now this is the position: 25 on X, 150 on Y, and 1000 on Z. So I will make now go reference point. Now what is the XYZ for the reference point? I will copy paste this. Copy, paste. I will just increase the Y a little bit. 150, I will make it like 170 for example. And I enter. Now I have my reference point above this point. Here I will apply the load using this reference point, and I will give this reference point a set. Create set, what I will call it RP1. Okay, and choose this. Done. Now I have set for this RP. Now I will go to step. We back step again. We have created a step. I will create field output and history output. Okay, later I will create them. I will go to interaction. I have to make an interaction between reinforcement and concrete. Because even if the reinforcement inside the concrete, if there is no interaction between them, they will not behave together. It's like inside the concrete at all. So we must put a constraint. Create constraint. I call it concrete reinforcement. Yeah, and I will choose embedded region. Continue. Select the embedded region. I have to select the reinforcement, but since I cannot select it because of the beam, I have to go back to this order, to this tool, create display, beam, remove the beam. Now I can see the embedded region. I choose the reinforcement. I said done. Now select the method of host region. Is it the whole model? No, it's not the whole model, it's only the beam. So select region. I want to choose the beam, but the beam is not visible. I go back here, I saw the beam, but this time I replace. So everything will go, but only the beam will occur. I choose the beam. Done. This I will leave it as default. Okay. Now the constraint between reinforcement and beam has been created. Now show replace all. So everything I can see now. Now interaction is done. I will go to load. I will apply here load. I will apply the boundary condition and the loading. Create boundary condition. In which step? The boundary condition will be in the initial step. Let's say left, or like pin, mechanical displacement rotation. I will choose. Okay. Now he's telling me select the region. Okay, let's select the region. This is the region. I'll choose this line. Also, sometimes it's like it may be not the line. It may be also area, as I said, for the loading. But here I just choose this line. I can choose, like, for example, all this, but I will choose only this line as shown here. Okay, done. Now what you want to fix or constrain here, I want to constrain the U1 for X, U2 for Y, and U3 for Z. The rotation, leave it, since it's spin, its rotation, there will be ability to rotate. Say OK. Now it's shown here. Again, I have to put roller here. BC2, I will call it roller. Also, initial step, displacement, continue, select the region. This is the region. Done. Only U2. All others will be open. Now I have here create a roller. Now this is the boundary condition. I will go for the loading. Either I will apply a load, or I will make it a displacement control. Displacement control is much better because it will be able to capture the behavior of the beam after failure in a better manner than the load control. So I will apply loading here, I'll call it loading. And it's not in the initial, it's in the loading phase. Mechanical displacement continue, where I applied on the RP. Done. It's on Y direction, minus, let's assume it will be like minus 20 mm, for example. And leave everything as it is, uniform and round. Okay, now it's showing, see, it's downwards. But this load is being applied on the RP point. And this RP point is not related to anything. I didn't put any constraint between the RP and the concrete beam. So I have to make a constraint. I'll go back to interaction, make constraint. It will be coupling between RP concrete or RP beam, if I can say that. Coupling, continue. The couple, it will be like between point, constraint, it's the RP. And it's a surface or node region, this is here I will apply the load. I say done. Now what you wanna constrain degree of freedom, I will leave it as it is default, but you also can uncheck the rotation and U3, U1 since it's only in Y direction, but leave it. Now the constraint is made and you can see these kind of lines to refer to the constraint between RP, the point, and the concrete. Now I have defined the load, I defined the step. Before going to mesh, I now go back to step and I will define the field output and the history output. The field output, cancel it. Here it will be already, there is one. I just edit. Here he's showing what kind of data or like you want to show as an output after applying the load. Here he's showing this as a default. I will remove all of them. I want to show stresses and mises. I want to show strain E and the equivalent plastic strain. I want to see displacement. I want to see also like reactions and forces. The failure, absolutely, since it's a concrete. I want to see the damage, the compression damage and the tensile damage. That's it. And also it's recommended to check the status. And that's it. Here I will leave it as it is, or here for the whole model. Every n increment means like for each increment, these data will be collected. If you want to minimize the time, you can increase these increments. Like for example, each 50 increments, he will collect these data. For now, I'll put it as 1, no problem. I'll leave everything as it is. Okay. Now the field output is created. Now the history output, we use it like if I want to have data on something specific. Here also is something default for energy. I will uncheck it. I will not the whole only set. I only created one set, which is the RP, and this is what's shown here. because here in the RP I want to know the reaction here and the displacement to make a curve of force displacement curve for the RP. Also here in every n increments, yeah, every n increments. Okay, what you want to know? I want to know the displacement in y direction, u2, and I want to know the forces with the reaction in also y direction, and that's it, nothing else. Leave everything as it is. Okay, dismiss. Now I will go to mesh. Since I have when I did the assembly, I choose dependent on like mesh on part dependent. So when I go to mesh, I cannot do it in assembly. I have to go to part. Now each part I have to mesh it. I have like seed part. You can choose the size of the mesh. I will choose like 50, for example, as a beginning. Apply. Okay. Then what is the element type you wanna? C3D8R. Here it can show the name. Here you can say quadratic or anything. Whatever changes you do here, it will reflect on the name of the element. For example, if I say quadratic, now it's C3D20R. But no, leave it linear. Okay. Now mesh, please. Mesh part. Yes, I want to mesh the part, and this is the part meshed. Go to the reinforcement. I will choose the same mesh size. Okay. And what is the mesh? It's B31. No, it's beam. I choose truss. T3D2. 2 node linear 3D truss. Okay. Mesh the part. Yes, please. And go stirrup. The same thing. Choose 50. Okay. Done. B, no, not B. Truss. Okay. Mesh. Yes, please. The top. Also choose 50. Choose 50 because we have already chosen 50 for beam and others, so it will make like kind of compatibility, more compatibility. If I'm right in using this term. No, this is B, no, truss. Okay, mesh, yes. Now I have meshed all the parts. I can go back to assembly, and now everything is meshed. Now I can go to job, create job, continue. I will leave everything as it is. Okay. Now here I can first do a data check to know that I have no problem in my model. Let's do the Java is exist. It's already there. I said okay, overwrite it. Let's see. Check submitted. Running. Can see monitor just to see completed. So check completed. So everything is successful after I checked everything. Now I can go and submit the job and see how the behavior will be. And this is everything for this module. And thank you for your time.